August 6, 1945. Farm Hall, England. 10 German scientists sit in comfortable chairs at a country estate 30 miles north of Cambridge, drinking tea and discussing physics. They've been held here since May, guests of British intelligence. Not quite prisoners, but specimens under observation. The house is bugged. Every conversation recorded. The British want to know what these men know about atomic weapons. Werner Heisenberg, 43, Nobel Prize winner and discoverer of the uncertainty principle, sits near the window. He's confident. Germany's atomic program didn't succeed before the war ended, but he knows they were close. Closer than the Allies, probably. German physics is the best in the world. At 6 p.m., a British officer enters with a radio. The BBC is about to broadcast something important. The announcement is brief, clinical. An atomic bomb has been dropped on Hiroshima, Japan. The city has been destroyed. The bomb was American. The room goes silent. Then someone laughs, not cruel laughter, but disbelief. That's impossible, one scientist says. The Americans don't have the theoretical knowledge. Heisenberg stands, walking to the radio as if proximity will make the words make sense. It must be propaganda. Or perhaps a very large conventional bomb. But the broadcast continues. One bomb, one aircraft, an entire city. The Americans are calling it an atomic weapon, releasing energy through nuclear fission. Otto Hahn, who discovered nuclear fission in 1938, puts his head in his hands. If this is true, I am responsible for the deaths of hundreds of thousands of people. The scientists crowd the radio, no longer listening but arguing, calculating, trying to understand how America, a nation they considered scientifically inferior, could have built an atomic bomb while Germany, the birthplace of quantum physics, had failed. What none of them know yet is the scale, the sheer overwhelming industrial scale of what America had accomplished. Germany's atomic program employed roughly 70 scientists at its peak, with a budget measured in thousands of Reichsmarks, operating from a few laboratories and one experimental reactor in a cave. America's Manhattan Project employed 130,000 people. It spent $2 billion. It built entire cities that didn't exist on any map. It consumed more electricity than some countries produced. And the Germans had no idea any of this existed until they heard it on the radio. Let's go back to 1939, before anyone thought atomic bombs were possible. Nuclear fission had just been discovered. Otto Hahn and Fritz Strassmann in Berlin split a uranium atom and measured the energy release. Theoretical physicists immediately understood the implications. A sustained chain reaction could release energy equivalent to thousands of tons of explosives from a piece of uranium the size of a grapefruit. Germany had advantages. German physics was dominant. Einstein, Heisenberg, Planck, Born, Bohr, the foundations of quantum mechanics had been laid in German universities. When scientists worldwide discussed atomic theory, they used German terminology. Werner Heisenberg was the obvious choice to lead Germany's atomic research. He'd won the Nobel Prize in 1932 at age 38, brilliant and fiercely loyal to Germany, despite his complicated relationship with the Nazi regime. The Uhrenverein, Germany's uranium club, began work in September 1939 with about 30 scientists. But they were good. Carl Friedrich von Weizsäcker, Karl Wirtz, Walther Bothe. These were established physicists who understood nuclear theory as well as anyone alive. Heisenberg's team made rapid progress. By 1940, they'd calculated the critical mass needed for a chain reaction at around 50 kilograms, close to the actual 52 kilograms. They understood that natural uranium needed enrichment to concentrate uranium-235, or that uranium-238 could be transmuted into plutonium-239 in a reactor. By 1941, German physicists had the theoretical framework for an atomic bomb. They knew how to do it, but then they made a calculation that would doom the program. They asked, how much will this cost? How long will it take? Is it worth it? Heisenberg's team estimated enriching enough uranium for one bomb would require massive industrial facilities, enormous electricity, thousands of workers, years of construction. The cost would be astronomical. Germany was winning the war in 1941. France had fallen. Britain was isolated. The Soviet invasion was progressing. Why spend enormous resources on a weapon that wouldn't be ready until 1945 or 1946? In June 1942, Heisenberg presented his findings to Albert Speer, the Minister of Armaments. Speer asked the critical question, how much will it cost? Heisenberg's answer, more than we can afford during wartime. Speer made his decision. Germany would continue atomic research at low priority, no massive industrial commitment. The physicists could work on reactors and basic science, but building a bomb, not worth the investment. This decision was entirely logical. Germany's war economy was already stretched. An atomic bomb ready in 3 years was a luxury Germany couldn't afford. What Heisenberg didn't know was that America was asking the same questions and reaching very different conclusions. In October 1939, Albert Einstein signed a letter to President Roosevelt warning that Germany might be developing atomic weapons. Roosevelt's response was cautious. The Uranium Committee received $6,000 to investigate. Pearl Harbor in December 1941 changed everything. By 1942, the Manhattan Project was born. Not an academic research program, but an industrial mobilization on a scale never before attempted. General Leslie Groves was put in charge. He wasn't a physicist. He was an engineer who'd overseen construction of the Pentagon. Groves understood logistics and large-scale construction. When told to build an atomic bomb, he approached it like building a city, which is exactly what he did. Oak Ridge, Tennessee was farmland in 1942. By 1945, it was Tennessee's fifth-largest city with 75,000 residents. It housed 3 uranium enrichment facilities using 3 different methods: electromagnetic separation, gaseous diffusion, and liquid thermal diffusion, all running simultaneously because nobody knew which would work best. The K-25 gaseous diffusion plant was the world's largest building, covering 44 acres under one roof. It consumed so much electricity that new power plants had to be built just to feed it. Hanford, Washington was another city built from nothing for plutonium production, eventually employing 50,000 workers. Los Alamos, New Mexico was the design laboratory where Robert Oppenheimer concentrated more scientific talent than anywhere in human history. All completely secret. 130,000 people working on a project most didn't understand. The cost, $2 billion between 1942 and 1945, roughly $30 billion in today's dollars. Germany's entire wartime research budget across all projects was a fraction of this. America won not because American physicists were smarter. Many of the Manhattan Project's key scientists were European refugees like Fermi, Bohr, Teller, Szilard, and Bethe. America won because it could afford to try everything simultaneously. When German scientists calculated the cost and said it was too expensive, American planners said, "We'll spend whatever it takes." The Germans had better physics initially. But physics doesn't build bombs, industry builds bombs. Back at Farm Hall on August 6th evening, more details come through. The bomb used uranium, was dropped from a B-29 and had a 20-kiloton yield. Heisenberg is at a chalkboard, calculating whether the Americans are lying. His calculations keep returning to the same conclusion. It's possible, but the engineering required. How much enriched uranium would you need? Someone asks. At least 50 kilograms, probably more. How long would it take to enrich that much? Silence. That's the question revealing everything. Enriching 50 kilograms requires processing tons of uranium ore, enrichment cascades with thousands of stages, enormous electricity, years of work by thousands of people. They must have started in 1942, Heisenberg says quietly, maybe earlier. While Germany decided atomic bombs were too expensive, America was already building the factories. Otto Hahn still sits with his head in his hands, devastated that his life's work has been weaponized on this scale. Others react differently. Some are defensive. German physics is still superior. The Americans just threw money at the problem. Karl Wirtz is angry. We told Speer it was possible. He didn't listen. Heisenberg is most conflicted. He'd spent 3 years believing Germany's bomb program was ahead. Now he's confronting the possibility they were never even close. Over the following days, more information filters in. The Manhattan Project employed 130,000 people, more than Germany's entire aircraft industry at its peak. The cost was $2 billion, more than Germany spent on all military research during the war. 3 cities built from scratch, all secret. The K-25 plant alone used more electricity than Berlin. When these numbers sink in, the German scientists stop arguing about physics and start arguing about economics and politics. We were trying to win a scientific race, one scientist says. They were fighting an industrial war. Germany's approach had been economical, efficient, targeted. Do the theoretical work first, then build if feasible and affordable. America's approach was extravagant by German standards. Build everything simultaneously. If unsure which method works, try all of them. Don't wait for perfect information. Act. In peacetime, the German approach would have been smarter. But in total war, when time matters more than money, the American approach was unstoppable. On August 9th, news reaches Farm Hall of a second bomb, Nagasaki. This one used plutonium. They have 2 types of bombs. This reveals even more about scale. America hadn't just built one bomb, they'd built an entire production infrastructure. a weapons program, not a science experiment. Heisenberg finally admits what he's been avoiding: we never had a chance. Even with unlimited funding in 1942, we couldn't have built this. Germany doesn't have the industrial capacity. We don't have the electricity. We don't have 130,000 people to spare. We were trying to win with cleverness what they won with resources. Carl Friedrich von Weizsäcker puts it differently: we thought we were the best physicists in the world. We were. But that didn't matter. They had better logistics. The numbers are devastating when lined up. Germany's Uranverein, 70 scientists, a few million Reichsmarks, one experimental reactor, no enrichment facilities. 0 grams of enriched uranium or plutonium produced. America's Manhattan Project, 130,000 employees, $2 billion, 3 cities built from scratch, multiple enrichment plants, multiple reactors, 2 bomb designs. Enough enriched uranium for 1 bomb and plutonium for 2 by August 1945, with production facilities just getting started. The gap wasn't close. It was a chasm. And the German scientists hadn't even known the race was happening at this scale until they heard about it on the radio. Werner Heisenberg lived until 1976, spending his post-war years carefully crafting his legacy. He maintained that Germany's bomb program failed because he and other scientists quietly ensured it would fail through subtle sabotage. The historical record doesn't support this. The farm hall transcripts, declassified in 1992, show scientists shocked by Hiroshima, who believed they'd been ahead and who slowly realized they'd been beaten by an industrial approach they never imagined. Heisenberg wasn't a villain. He was a brilliant physicist who made reasonable calculations based on Germany's resources. His mistake was assuming America would make the same calculations. America didn't calculate whether they could afford it. They decided they couldn't afford not to build it. Then they did whatever was necessary. The Manhattan Project wasn't primarily a triumph of physics. It was a triumph of organization, project management, and logistics. An industrial system mobilizing resources on a scale no other nation could match. German physicists were better trained with more experience. They'd laid the theoretical foundations. None of it mattered. Because America had something more important: 130,000 people willing to work on a secret project they didn't understand, in cities that didn't officially exist, on an impossible timeline, at an insane cost. And it worked. The story of the atomic bomb is usually told as genius: Oppenheimer's brilliance, Fermi's experiments, Einstein's equation. Those things mattered, but the real story is logistics. It's what happens when you point industrial capacity at a scientific problem and say, solve it, cost is no object. Germany thought about whether they could afford to build a bomb. America just built it. That difference, more than any physics breakthrough, decided who won the atomic race. Werner Heisenberg thought Germany was winning. He was wrong, not because of bad physics, but because he was calculating the cost, while America was calculating the consequences of not having it first. Sometimes the most important equation isn't physics. It's resources multiplied by will. America had both, and that made all the difference.